You are running your application workloads as deployments on a Kubernetes cluster, but you have a lot of environments. You have dev, test, stage, prod. And for some of the environments, do you even need the workloads to be running 24 by 7? Don't you think you need to put those workloads to sleep? Let's say I have a Kubernetes cluster and I want my workloads in dev, test, and stage environments to sleep at night when the developers are sleeping. Who wouldn't want that? That reduces the cost, increases the resource optimization, and also makes the best use of resources available within your Kubernetes clusters. So you can have that, and then with the cluster autoscaler integrated, it will scale down the node and you will save cost, and you will also run the Kubernetes in a more sustainable way. But it's not that simple, only if you are not using vCluster. So hold your horses, because today I'll be showcasing you one of the coolest features of vCluster 022 that introduces native sleep mode functionality for the workloads. So without wasting time, let's get started and see it in action. vCluster 022 enables you to scale down Kubernetes resources such as deployments, replica set, replication controllers, D1 set by putting them to sleep. And you need not install any third party tooling in order to do that and write those configurations in. vCluster will handle that for you. So as mentioned before, a lot of benefits: cost optimization, resource optimization, dynamic scaling, simplified management, sustainability. All of these come when this particular feature is enabled. So let's try to see everything in action from scratch end to end. So this is a killer coda playground. You can use any Kubernetes clusters and the command should just run fine. So right now we have a 2-node Kubernetes cluster that is there that we get with Killer Coda Playground, which is a scenario that you can also sign up and try to use this particular feature for free, or you can do that on your kind cluster or AKS, GKS, GKE, or EKS. So the first step is we need to install. So the first step is we need to install obviously vCluster CLI. So that's what we are going to do. We are installing the vCluster CLI. Now, vCluster CLI is there. The next step is to log in. Now, this particular feature is a pro-only feature, and for that, you need to either you can do vCluster platform start, and it will start an agent, and then you have to sign up, or simply you can go and use vCluster.cloud. So I already have my vCluster account set up on the vCluster cloud, and what you can do is you can go to your profile, access keys, create a new key, select all projects. There's the YAML that it gets created, and save changes. It will give you the key. I'll just copy the key later, but first I'll type this command. So vCluster login or vCluster platform login, and the access key, I'll mention this one. Don't worry, by the time it reaches to you, I'll delete the key at the end of the video. Now you can see I logged into my vCluster account and it is done successfully. So we are logged in and we are able to use this particular feature. Now let's create an experimental file. Now let's create a vcluster.yaml file. So vi vcluster.yaml, and this is an experimental feature. Sleep mode we enable true. Now we put auto sleep after the inactivity of 2 minutes. Now here the 2 minutes is done only for demo purposes, so that I can just show you how within 2 minutes it will go in the terminating state. And if we want to exclude some of the workloads that we do not want to sweep, and some workloads should actually be running, like the Ingress controller, which I'll be showcasing. So you can exclude that by adding the label. So label don't sleep. We'll see how to add that as well. So vCluster create demo -f vcluster.yaml. Now it has started to create the vCluster with the configuration that we have provided. We wait for some time, let the vCluster be ready, and then we'll continue deploying our workload. In some time, vCluster got ready, and when we do vCluster list, we can see that the status is running. Also, when we do kubectl config get context, the context is actually changed to the virtual cluster. So kubectl get pods -a will give me the pods that are only there inside the virtual cluster, which is fine. That is what we want. Next step that we want to do is we want to create and expose a deployment, a very simple deployment. kubectl create deployment nginx. So deployment with the name of nginx and the image nginx with 3 replicas. That should create kubectl get pods, and it's in container creating. So right now everything is perfectly fine. Next step is we want to install the Ingress Nginx controller. So that's what we are doing. Help repo add Ingress Nginx and giving the URL, and then help install with some of the flags like the namespace and setting the controller host network true, DNS policy cluster first with hostnet, and the service type as cluster IP. So the Ingress controller is installed, kubectl get pod -a. We can see everything is running, and the Ingress controller is just getting ready. It's 0 out of 1 at the moment, but it should be very soon ready. So we'll now create an ingress.yaml file. Let's copy this, vi ingress.yaml. A very simple ingress file, and also if the ingress class is not there, then let's add that as well. So we are saying the mirror target is enabled, and ingress class name is nginx, and the host. Now here the host we need to change because we need to get the svc for the nginx ingress controller, which is this. So let's edit that. Now we are okay. kubectl apply -f ingress. There, kubectl get ingress. We get this curl, and it's running. Welcome to nginx. So now everything is running fine. Our cluster is created. Let's go to tab 2 and let's do kubectl get pods -a and w. Before that, we also want this particular pod not to sleep and only these ones to sleep. So what we'll do is we'll label the deployment for Ingress Nginx with don't sleep. And if you remember our vCluster.yaml file, this is the label that we kept. Now we wait for 2 minutes and we'll exactly be able to see the pods which are there. The Nginx pod should go to terminating, but the Ingress Nginx pod should remain as it is because of the label. It should respect the labels. And then we'll try to see how to wake it up by just making an Ingress call. And we can see that the pods have started to terminate, but the pods which are terminating are only the nginx pods, and there is no other pod which is getting terminated. Nginx controller pod is saved because we added the label to the deployment. Now, in order to wake that up, let's do a curl again. Yes, it starts the pod. And here we go. Welcome to Nginx. So the time taken to get the response is only the time taken for the pod to get into the running state, which is just 2 seconds. So within 2 seconds, you are able to again wake up the pod whenever the request comes, and it respects the ingress incoming request and wakes it up. A very efficient way to sleep your workloads without installing any third-party tooling onto your Kubernetes cluster. Just you have to use vCluster, and yes, if you are using vCluster Pro, you already have that feature available that you can create your vClusters with and put your workloads to sleep. So I definitely think that the vCluster sleep mode going to the workload level is a game changer when it comes to resource and cost optimization. This is an experimental feature. Try it, use it, let us know what are the caveats, where it works. If you are facing any issues, join the Slack channel. Make sure to subscribe to vCluster YouTube channel, and see you in the next video. Bye.